All right, let's talk about blood now, okay? And blood is going to have a lot of different components. When you say about blood, you're asking what is blood? What is it made of? Okay, it's going to be made of two things. Okay, blood is going to be made of something called plasma and cellular elements or cells. Okay, simple as that. Now, 55% of blood is going to be plasma. 45% of blood is going to be cells. And actually, to be even more precise, uh, technically, 44% is going to be like erythrocytes, like white blood cells, and just like 1% is going to be leukocytes, which are white blood cells. Okay, unless you have an infection, or unless you have something, then that's different. Okay, then you have to, then the white blood cell number will increase. But otherwise, normally you're just going to have like about 1% of white blood cells. Okay, so plasma. We said that 55% of blood is going to be plasma. So what's in the plasma? I want you to know the constituents, what it is, and the major function. Okay, so water, obviously, right? One of the main components of plasma is water. Okay, why? And what is water? What's the function of water? Solvent. It's going to dissolve all the stuff that's in the blood. Okay, so water, mean. What else do we have in the blood? Ions. Okay, electrolytes. Like sodium, potassium, calcium, magnesium, chloride, bicarbonate. Okay, especially bicarbonate is important because this is it's going to be helping in the pH buffering. Okay, it's going to be great for buffering the pH to keep the pH at a normal level in the blood. The pH in the blood is around, it's I think 7.4. Okay, so it's 7.4, that's the pH. So as you can imagine, to maintain homeostasis, you have to keep at 7.4. Okay, so bicarbonate ions are great at that. They're great buffers. Okay, and also for osmotic balance. Okay, now what else? What else is going to be in the blood, in the plasma? Proteins. You have a lot of proteins. One of the most important ones are albumin. Albumin is going to help in osmotic balance, kind of keep the concentration of solutes of water at the right level, and also for pH buffer. Okay, immunoglobulins, better known as antibodies. You have a lot of antibodies, and antibodies are proteins. Okay, defense and immunity. Proteins, I'm just know that they are. I don't want you to learn that one. And fibrinogen, which is going to be very important, especially for blood clotting, and we'll talk about it in a second. Okay, is that it? No, there's other stuff in the blood. And remember, why do we use? What's the main thing about blood, right? Nutrients, glucose, fatty acids, vitamins, all of this stuff is needed, right? So a lot of it is going to be traveling in the blood. What about waste? Yeah, exactly. For example, products of metabolism, and also respiratory gases, oxygen and carbon dioxide. Some of these gases, so a little bit of them are carried in the blood. Okay, we'll talk about that later on. And also important hormones. Hormones are chemical signals that are not tell certain cells to do something. Okay, so anyway, hormones are important that they're also part of blood. So nutrients, waste, okay, gases, and hormones. Okay, that's plasma. Now, 45% of the blood is going to be cells or cell type stuff, right? And white blood cells, know your white blood cells: basophils, lymphocytes, eosinophils, neutrophils, and monocytes. We'll talk about this more detail in another chapter. But know that white blood cells, know which ones are the white blood cells, what are the names of the white blood cells, and also know what's their function, which is mostly for defense and immunity. Okay? Platelets. Platelets are not cells, actually. Platelets are cell fragments. So there was once upon a time, there was a cell called a megakaryocyte that exploded, and this explosion made a bunch of cell fragments called platelets. What's their function? We'll talk about them in a second, but blood clotting it is. And then finally, erythrocytes, I usually call them RBCs because that means red blood cells. And there's so many, and what do they do? Kind of the main thing, obviously, carry oxygen. It does carry some carbon dioxide as well, okay? But the main job is this, okay? That's what we need to survive. Platelets are cell fragments. They function in blood clotting. They function in blood clotting. Coagulation is the formation of a solid clot from liquid blood, okay? And there's a cascade of complex reactions that converts inactive fibrinogen to fibrin, which helps to form a clot. I want to tell you something what I want you to know here. What is a clot? I want you to know that it is pretty much platelets, okay, plus fibrin, called fibrin mesh, okay? And I'll show you that in a second. Okay. All right. So this is what happens whenever you bleed. Okay. When you cut yourself. Okay. Let me use my hand here. So the clotting process, again, it's kind of it's a step. Okay. And these are the major steps that I want you to understand. So what happens is in the clotting process, well, your endothelium, your vessel is going to be damaged. Okay. It's going to be damaged. You can see all this damage here in the endothelium. So it's going to break. Okay, and that's going to send signals. Okay, that's going to send signals, bringing other cells into the area. Okay, and the platelets are going to adhere. You can see this is a platelet over here. It's going to start to adhere to these collagen fibers. Okay, this collagen tissue, and it's going to start releasing a substance that make other platelets here sticky. Okay, eventually what you end up getting is something called a platelet plug. Okay, a bunch of platelets are joining here, and they're gonna make a platelet plug. It's just like, I don't know what it is. I don't can't find an analogy here, but you know, I don't know, thing like something breaks and you put a bunch of tape or something on top, right? Just to make a little plug. This is good because it prevents you from bleeding out, right? So that's the first thing that happens. The platelet plug is nothing but platelets all together, all sticking together. Okay, pretty much a band-aid. Now, what happens then? Okay, what happens is this: clotting factors. Okay, they're gonna come from the platelets, from damaged cells, even from plasma. Okay, from like the liquid part of the blood. Okay, all of this. Okay, I wanna cause an enzymatic activity. Okay, enzymatic cascade, which is going to make pretty much activate prothrombin into thrombin. And thrombin then is going to be able to catalyze this reaction where it activates fibrinogen. So fibrinogen is inactive, and fibrin is going to be the active form. Okay, so thrombin itself is an enzyme that catalyzes the final step of the clotting process, the conversion of fibrinogen to fibrin. And the threads of fibrin then become interwoven into a clot. We usually call it a fibrin mesh. Okay, and you can see that over here. Okay, that's going to be the stuff here. Okay, all this stuff. That's going to be the fibrin mesh. Okay, so again, what is a clot? Well, a clot is pretty much involves both things: platelets and fibrin mesh or fibrin clot.